let's go to page 81 and start with number 1. So you have the point Q is a 3 over 5 and 4 over 5. So you want to verify that the point Q lies on the unit circle. Unit circle means radius is equal to 1. So you just use the Pythagorean Theorem. Okay, so you just going to have a, so you just have to verify, you just do this. Okay, and this will equal to r squared, right? So a squared plus b squared equal to c squared. So when you simplify, you're going to get 9 over 25 plus 16 over 25 equal to r squared. So you're going to get 25 over 25 equal to r squared. So r squared equal to 1, so r equal to 1. So again, so it checks, right? So again, radius is 1. So that's your, so this point is on the circle with a radius of 1. Okay, so that's what it's saying. Okay, so now you want to find exact value of the 6 trigonometric function. Okay, so to do that, again, if you, so this is going to, you can just ignore the denominator for now. So it will be 3, 4. So it's going to be a 3, 4, 5 triangle, spatial triangle. So it will be 3 over 5, 4 over 5. So you can use your geometry. So it will be 3, 4, 5 spatial triangle. Okay, so basically what you have. Okay, so again 3, 4, 5. Okay, so sine theta. Sine is this over this, so this will, the denominator will cancel out, so you're going to get 4 over 5. Okay, because radius is equal to 1 anyway, right? So this over 1 equal to 4 over 5. And cosine theta would be this over this, so it would be 3 over 5. And tangent theta is equal to opposite of adjacent would be this over this, so again the 5 will cancel, so it would be 4 over 3. Okay, so once you get the 3 primary, you can get the secondary, so you just go and take reciprocal. So sine go with cosecant, so it would be 5 over 4. Cosine go with secant, so it would be 5 over 3. And cotangent would be reciprocal, that would be 3 over 4. Okay. Okay, number 3, the point Q is at 1 over square root of 2, 1 over square root of 2. And for this, I'm going to just multiply by, I'm going to get rid of the square root on the bottom. So if you multiply by square root of 2 over square root of 2, you're going to get square root of 2 over 2. Square root of 2 over 2. Okay, so again, you just multiply by square root of 2 over 2, and then you will cancel, you get that. Again, you can do that, so I'm not going to do it. You can just go and do that. You can see it's going to also equal to 1. Okay? Okay, so if you were to sketch that, so this is your 45, 45 spatial triangle, right? So it'd be, so from your geometry, this is going to be a 45, 45 spatial triangle. Okay, so you're going to get sine theta is equal to this over that, so it'd be square root of 2 over 2. Cosine theta equal to this over that, so it'd be square root of 2 over 2. Tangent theta equal to this over this, so they are the same, so this over this will equal to 1. Okay, so cosecant, now cosecant, instead of flip this over, I'm going to say they are the same, right? So if you flip this over, you have to simplify. So be smart. So I'm going to flip this over, so it'd be square root of 2. Okay? Same thing with secant theta. Okay, so secant theta, okay, I'm going to flip this over, but this is same as this, right? They are the same. Okay, so when I flip this over, I get square root of 2. Okay, and cotangent, if I flip this over, I get 1. Okay. Now, if you don't see that, you can just go and flip it over. You get 2 over square root of 2, and then you can multiply by square root of 2 over square root of 2, and you get 2 square root of 2 over 2, and this cancel out. Okay, so you get that. So just a little bit of algebra. Okay, let's go to the next one. Okay, number 5. The point Q is a negative 1/2 square root of 3 over 2. Again, this is one of your spatial triangle. So x is negative 1 over 2, and then y is square root of 3. So this is short, this is long. Okay, so negative 1/2 and square root of 3 over 2, and this is 1. Okay, again, that's your spatial triangle from your geometry, so make sure you know that. Okay, so sine theta is this over this, so it would be square root of 3 over 2. Cosine theta equal to this over this, so it would be negative 1/2. Okay, tangent theta equal to this over this, and the 2 will cancel out, so you're just going to have a, so this over this would be negative square root of 3. Okay, and then after that you get the secondary function, so cosecant equal to, you have to flip this over, so it would be 2 over square root of 3, and then if you simplify, so equal to 2 square root of 3 over 3. Okay, let's get rid of this line. There we go. Okay, and secant, it would be flip this over, so it would be negative 2. And cotangent theta, you flip this over, you're going to get negative 1 over square root of 3. And then you simplify, so you go to negative square root of 3 over 3. Okay. Okay. Number 7. Find exact value of each of 6 trigonometric functions. Okay, so it's same thing. It's the same as before. So point P is A6. Now this one you don't even need to use a graph paper. You can just go ahead and do so. So you can just, as long as you keep track of the long and short. So this is long, and this is short. Okay, so it'd be 8, 6, and again this is your Pythagorean theorem. So 6, 8. This would be a 10. Okay, and the way to do that is this. So you got 6, 8, and you got a hypotenuse. Call it x, right? Actually, let's go and call that c, hypotenuse, c or r, right? So what you can do is factor the 2, so you get 3, 4. Okay, and from the geometry, the 3, 4, 5, then that's hypotenuse would be 5, right? 3, 4, 5 is triangle, and so you just go backwards. So 5 times 2 give you 10. That's how I get 10. So 6, 8, 10. Right? Okay. So sine theta equal to this over that, so it'd be 6 over 10, so equal to 3 over 5. Okay, cosine theta equal to this over that, so equal to 8 over 10, equal to 4 over 5. Okay, and tangent theta equal to this over that, so it'd be 6 over 8, so equal to 3 over 4. Okay, then after that, you get the secondary function. So cosecant theta, you flip this over, so it'd be 5 over 3, and secant theta, flip this over, you get 5 over 4, and cotangent theta, you flip this over, so you get 4 over 3. Okay. Okay, let's go to the next one. Okay, number 9. The point is at -7, -24. Okay, so you can just keep track of which is long, which is short. So this is short, so you go short, and this is long, and it's negative, so you're going down this way. Okay, so it's -7 and -24. And again, to your spatial triangle, this is your spatial triangle, 7, 24, 25. Okay, so and if you don't get that, what you do is you go ahead and use the Pythagorean theorem. So a squared plus b squared equal to c squared, and you can get that. Okay, so sine theta equal to this over that, so it would be -24 over 25. Cosine theta equal to this over this, so it would be -7 over 25. Tangent theta equal to sine over cosine, so it would be this over that, the negative it cancels out, so equal to 24 over 7. Then after that, cosecant would be -25 over 24. Secant would be this over that, so it would be -25 over 7. And cotangent theta would be equal to 7 over 24. Okay. Okay, number 11. The point P is a -12, 5. Okay, again, that's your spatial triangle. So just keep track of your long and short. So negative 12 is over here, and 5. So this is long, so this would be short. Okay, so just make it long, short. And then draw your triangle. So negative 12, and this is 5, so this would be a 13. So this is a 5, 12, 13 spatial triangle. Again, you have to know that from your geometry. If you don't, then you just have to spend time to use Pythagorean Theorem. So a squared plus b squared equal to c squared. Okay, so sine theta equal to this over that, so it would be 5 over 13. Okay, cosine theta equal to this over that, so it would be minus 12 over 13. Then tangent theta equal to this over that, so it would be negative 5 over 12. I kind of put a negative on the top. Okay, okay, so once you get the first three, then you get the secondary function. So cosecant theta equal to 13 over 5, you just take the reciprocal. Secant theta equal to negative 13 over 12. And cotangent theta equal to negative 12 over 5. Okay. Okay. Let's go to the next one. Okay, number 13, you got sine theta equal to 3 over 5, and this is quadrant 1 angle, and looking for the trigonometric functions. Okay, so what you do is, so again, remember sine is the vertical or opposite of a hypotenuse. And so this is your 3, 4, 5 triangle. So basically what you have is, and it's quadrant 1, here is quadrant 1, so that's over there. So it means you have 3 over 5. So from here, 3, 5, you get that. And again, from your spatial triangle, this would be a 4. Okay, so that's your 3, 4, 5 triangle. So you have to first have to figure out what quadrant, and then get your angle, get your triangle, label all 3 sides, and then from there you can get your function. Okay, so I'm going to write all 6 again. So sine theta equal to 3 over 5, that's giving. Cosine theta equal to this over that, so it would be 4 over 5. And tangent theta equal to this over that, so it would be 3 over 4. Cosecant equal to 5 over 3, take the reciprocal. And secant would be 5 over 4. And cotangent would be equal to 4 over 3. Okay, and that's it. Okay, number 15. Okay, you have cosine theta equal to 5 over 13, and the theta is a quadrant 4 angle. Okay. So cosine is a horizontal over the hypotenuse. So this is kind of short. So you're going to get that. It tells you quadrant 4, right? And so this would be a 5, 13. So cosine is horizontal over hypotenuse. The hypotenuse is always positive. Okay. Okay, so from here you can see that it's going to be a 12, like 5, 12, 13 spatial triangle, and it's going down, so it'd be a negative. So you have to know your spatial triangles. So from here, once you again get your quadrant, get your angle, get 3 sides, then from there you write your function. So sine theta equal to this over that, so it'd be sine is this over that, so it'd be negative 12 over 13. Right? It's vertical over hypotenuse. Cosine theta is giving, or you can look at from here, it's this over that, so it'd be 5 over 13. And then tangent theta is sine over cosine, so this over that, so it'd be negative 12 over 5. So once you get the primary function, you can get the secondary function by taking a reciprocal. Okay. And that's it. Okay. Notice this is giving, but I always like to write this kind of together. So even it's giving, I kind of write it again. And so keep that as a habit. Go sine, cosine, tangent, and after you get the flip it over to get the secondary function. Okay, number 17. Here you have sine theta equal to negative 7 over 25. And this is a quadrant 3 angle. So quadrant 3, so that's going to be over here. So so it's going to be this way, this way. So you have to recognize when you have 7 and 25, so it's 7, 24, 25 triangle. So sine is a vertical, so this is -7, and this is 25. So from this I get this, okay? So once I get this number, I can get this. So this would be 24, the length would be 24, and since it's going this way, it would be negative. Okay. So again, once you get that, then you can write your 3 functions, okay? So sine theta is giving cosine theta equal to this over that, so it would be -24 over 25. And then tangent theta equal to this over that. The negative will cancel out, so it would be 7 over 24. So once you get the 3 functions, you can get a secondary function. So cosecant would be -25 over 7. And secant would be equal to -25 over 24. And cotangent theta would be equal to 24 over 7. Okay. Okay, next one. Okay, you have cosine theta equal to -1 over square root of 2. And this is a quadrant 2 angle. So quadrant 2 is over here. So you have to recognize that this is going to be a 45-45 spatial triangle. Okay, and another way of writing this is -square root of 2 over 2. Okay, if you multiply by square root of 2 over square root of 2, you get that. So you can use either one. Okay. Let's see, which one should I use? I'm going to probably use this one. So cosine is horizontal, so it would be -square root of 2 over 2 over 1. Okay, and so again, this would be square root of 2 over 2. Okay, so from there, you get your 3 primary functions. So sine is this over that, so it would be square root of 2 over 2. Cosine theta is giving is that, so it would be -square root of 2 over 2. Tangent theta is sine over cosine, so it would be this over this, and so it would be equal to -1, because they are the same, right? So same thing, something go over itself would be equal to 1, so equal to -1. Okay, then after that, cosecant theta equal to, so this is already giving, so if you flip it over, you get negative, let's do this one first. Secant theta, so they're the same, right? So instead of flip this one, you flip this one, so you get -square root of 2, okay? And so since they're the same, so this one, when you flip it over, you get positive square root of 2, okay? And then the cotangent theta, when you flip it over, you still get -1. Okay. Okay, let's go to the next one. We're going to skip the 21, so number 23. Okay, so use calculator to find the answer to problem 23 to 28 for significant digits, and say make sure you're in the correct mode. Okay. Okay. So you got sine of 62 degrees. Okay, so this is degrees, so make sure you have the DEG over here. And so this will equal to, so get your calculator, you go 62 sine of that, and 4 significant digits, so this will be 0.8829. Okay. Okay, next one, 25, tangent of 6 radian. Okay. Okay, so now this is a radian, so you have to make sure your calculator is in the radian mode. Okay. Okay, so it says RAD, so that's radian mode. Okay, so you go 6 tangent of that, so you go to negative 0.2910. Okay, so make sure you're in the correct mode. Okay, 27 secant of 4 radian. Now there's no secant on the calculator, so first you have to kind of convert that into the primary function. So secant is equal to 1 over cosine, right? Of 4 radian. Okay. So again, right now you have the radians. Okay. So you can go 1 divided by 4 radian cosine of that equal. And so this will equal to negative 1.529. So it'd be 30. So you want it off. So you can force significant digits. Okay, 29. Okay, cosine of 208 degree. Okay, so we kind of have to switch this back to the degree mode. Okay, so you get 208 degrees cosine of that. So this equal to negative 0.8829. Okay. Okay. Let's go to 31. You got cotangent of 312 degrees. Okay, so again, that's no cotangent over here. So first you have to convert it into 1 over tangent of 312 degrees. Okay, and so from here, so again, make sure it's in the degree mode because this is degree. Okay, so go ahead, 1 divided by 312 degree tangent equal, so equal negative 0.09004. Okay. Okay. Let me check this one again. I'm not sure if I remember to push equal. So I'm going to check this one again. Okay, so 4 cosine. Okay, so it's fine. Okay. Okay, next one. Okay, number 33. Okay, you got cosecant of 2 radians. So first again, cosecant, you have to flip it over, so it'd be 1 over sine of 2 radian. Okay. So make sure it's in the radian mode. So 2 sine of that, flip it over. Okay, so this is going to be equal to 1.09975. So you have to chop off over here, so it'd be equal to 1.100. Okay. So you can make sure you know how to round off to the proper number of digits. Okay, number 35. Sine of 11 pi over 7. Okay, so this is the radian. So I can make sure you're in the radian mode. So first I have to figure out what this number is. So I'm going to go 11 times pi divided by 7 equal. So that's what it's equal to. Then I'm going to take the sine of that. Okay, and that's it. So this is going to be equal to negative 0.9749. Okay. Next one, number 37. Secant of negative 1 radian. So again, first you have to convert this into 1 over cosine of negative 1 radian. Okay. Okay, so make sure radian mode. Okay, so go 1 negative, take the cosine of that, then 1 over that, so be 1x, 1 over x. So this is equal to 1.8508, so it'd be 51. Okay, again, 4 significant digits. Okay, next one. Number 39, cotangent of negative 22 degrees. Okay, so first convert into 1 over tangent of negative 22 degrees. Okay, then get your calculator. So make sure it's in the degree mode. Okay, so 22 negative, take the tangent of that and then you have to flip it over. So it'd be negative 2.475.